Ardeshir, thank you for agreeing to come and talk to us about structural equation modelling. First of all, could you explain precisely what structural equation modelling is?
Thank you for inviting me to come and talk about SEM. Basically, structural equation modelling is a kind of research methodology that allows us to test substantive theories. By substantive theory, I mean that you have a prior specified theory in language testing. It could be in language learning, or second language acquisition, or any other language-related areas. And then with this structural equation modeling, you're allowed to quantify your method and look at the relationship between your covariances. By covariances, I mean all your observed variables. Now, structural equation modeling is based on factorial analysis and regression model. What it means is that you start with factor analysis. Obviously, factor analysis are of two kinds. There is exploratory factor analysis, where you start with your data and you explore your data in order to come up with the underlying structure of data. And then there is a confirmatory factor analysis, where you start with your model and you test your data to see if it fits your model. SEM uses the latter, which means the confirmatory factor analysis. And then it uses the regression analysis in the sense of looking at the variances of different variables that you have in your data and tries to build them all together into a model, and then test whether the model that you have fits the data that you have. And by doing that, allows you to test your theory.
Okay, can you explain how an SEM study is conducted for us?
Well, there's usually 5 steps. There's 5 steps in doing an SEM study. The 5 steps are specification, identification, estimation, fit testing, and the last, if necessary, re-specifying your model. Let me briefly explain what that means. Now, in terms of specification, you have to start with a substantive theory. Now, the substantive theory should either be discussed and argued elsewhere in the literature, or could come from your own research. So you need to have a priori specified theory to start with. And that is what we mean by a specification of the model. Then we have the identification. Now, identification is about whether there is a solution to your problem. The reason we refer to solution is that in a structural equation modeling, you are dealing with a number of equations. And obviously, the equation need to be solvable. You have basically 3 positions. Either you have a model which is just identified. By just identified, I mean you have the same number of variables to be estimated as the number of variables which are known in your model, in which case you would have no degree of freedom. Your degree of freedom would be 0. That means your model is always right. And in that sense, it always has a perfect fit. Obviously, a model like that, which is solvable, fits your data, is of no interest to us. An example is an equation where you have two equations and 2 unknowns. There would be only one possible answer. On the contrary, you could be in a position that you have more unknown than given the information in your data, in which case the number of parameters to be estimated would be much larger than the numbers within your available data. In a case like that, there is no solution. to put it simply, it looks like you have one equation and two unknowns. Obviously, this cannot be solved. Now, something like that cannot be tested using SEM.
The third possibility is when you have an over-identified model. In an over-identified model, there are fewer parameters to be estimated than unique pieces of information in the variance-covariance matrix. It contains parameters for which an estimate is derivable.
You have lots of variables, known information in your data, and you have 3 parameters to estimate. That means you have a few degrees of freedom. The more degrees of freedom you have in your data model, the less likely your data model is going to fit the model you have, and it becomes much more difficult to prove. This is something that we're actually interested in SEM, and SEM models have a lot of actually known issues in terms of knowing the specific information within your test, and you try to estimate a few unknowns. And that's where we see the fit statistics relevant. Now, the next step in an SEM study is estimation. Now, estimation is all about a solution. Now, you have obviously you've got different methods of looking at your solutions. Most of the time, because you're doing some sort of solving some equation, we use techniques like maximum likelihood, in which case you have some assumptions about normality of your data. Obviously, there are techniques that can deal with a situation when you don't, your data is not normal and you violate your normality assumption, in which case you use tests like robust statistics. The fourth steps within an SEM is fit testing. Fit testing basically use different fits in order to evaluate your model. We have 3 types of fit testing. We got the absolute fit testing. There are a number of them. An easy example that a lot of people use is chi-square. Obviously, there is a problem with chi-square. We know that, and it's very sensitive to sample population. Then you have parsimonious fit testing, and there are a number of parsimonious fit testing. I just refer to one of them, which is the root mean square error approximation, or RMSEA. So the less it is, like less than 0.005, the better the model fits. And lastly, we have incremental fit statistics. And again, there are various incremental fit statistics in this particular case. One example that a lot of people use is called CFI, or comparative fit index. The last step within an SEM study is re-specification. Providing that you've done the first 4 steps, then you look at your model. If for any reason the data that you have does not fit your model, you try to do diagnostic testing and try to figure out what the problem is. In which case, you start looking at redefining your model and changing some of the relationship. Again, in this case, any re-specification you do has to be based on a priori theory.
As you mentioned, SEM should be based on a priori substantial theory, which means that it's really a tool for investigating the statistical predictions made by fairly strong theoretical models. But does this apply to applied linguistics and language testing, really? I mean, do we have theoretical models that can be tested in this way?
Well, it's the difficult question to answer. The answer is actually yes and no. Well, yes and no is a difficult position to be in. I say it all depends on how you define your strong theories. If you're thinking of coming up with one strong theory in applied linguistics that everyone can agree on that, the answer is no. An example I can bring about is the definition of the language proficiency. Now, a lot of people, including myself, have argued that there are different ways of capturing language proficiency. Now, in terms of coming up with one model describing what language proficiency is, you may not find a consensus in our field. People disagree with each other because everyone looks at different aspects of language proficiency. So from that perspective, you can never come up with a strong theory because no one will believe in one. But as Mark Lineker has recently indicated in his Messick lecture in LTRC 2011, what we have in social sciences is that in social sciences, people cannot agree on a strong theory. And actually, he argues that in the last 100 years, compared to physical sciences, there has been little advancement in terms of new theories. Partly that is due to the nature of social sciences. In physical sciences, you can make absolute claims because all observer variables are under your control. Whereas in social sciences, the observer variables are the tools, the reflections of what you can see about candidates. The answer is yes, in terms of whether we have substantive theory that can be tested with the SEM, because there are strong theories in our field. One example I can refer to is the work that John Oller did in the 1970s, where he came up with a strong theory of a unitary hypothesis. Now, when he came with the unitary hypothesis, it was really influencing at the time and impacted on a lot of practitioners. Now, we know that very late 70s, people with early versions of structural equation modeling, mainly confirmatory factor analysis, they demonstrated that such a theory could not be sustained. So we use SEM not to prove a theory, but to test a theory. So SEM can be used to test strong theories, and I'm sure there are many other strong theories that can be tested and using SEM to evaluate whether they can be tenable.
Thanks. In order to make the potential use of SEM clear, could you describe for us a few studies that have used structural equation modelling, and perhaps could you comment on the role of theory in those studies?
Well, I can think of three types of studies which were carried out in language testing, in particular applied linguistics. Well, the earliest one I can think about is the work that Gardner and his colleagues did back in 1987, when they looked at the causal model which link attitudes, motivation to language achievement, and use and retention, which was quite an influential work, I think, at the time, and influenced a lot of the teachers, language testers, and the people started looking at that. The problem with that study was that they were looking at a causal relationship between the two. And I remember that later that year, in 1988, Lyle Bachman, for example, he criticized this study on two accounts. One on the measures of proficiency that they were using, and the other one in the measures of language achievement they were using. So that was the first study I could think about. Then in the early 90s and late 90s, Anthony Kuhn did study about test taker characteristics and looked at the impact of test takers characteristics on test performance. And later on, towards the end of the 90s, Jim Purpura, he did studies about a language test strategy, and he's been doing that work for quite a while. And again, he looked at the links between the strategies of learners and the impact on test performance. The third group of categories I can think about is the kind of work that myself started back in 2004 and 5, where we looked at the investigation of the construct of the test in the context of the revision of major examinations, namely the first certificate in English or Cambridge First and Cambridge Advanced. what happened in this study, to my knowledge, is that factor analysis was not new. It was always used in revision of exams. But this was the first time that we started using SEM in order to explore the plausible model for a new version of a test. And that study helped shape the new format of the test that was to be revised. So that was an earlier study, and since then I think it has been used by other people. Another example I can think about is that more or less the same methodology was used in TOEFL IBT back in 2010.
And what do you think is the future of structural equation modelling? I mean, what kinds of outstanding questions do we have in language testing that you think could be addressed using structural equation modelling?
Well, I think in terms of the outstanding questions, the question is about the plausibility of the models. We said that in structural equation modeling, you are dealing with priori theory, which assumes that you should have a strong theory. But the methodology that we use in structural equation modeling, we use a null hypothesis to reject the alternative hypothesis. And what we achieved with SEM is basically rejecting the null hypothesis. Yes, by rejecting the null hypothesis, we control the variables that we think are irrelevant. But the problem is that we don't really know what happens within the mind of a learner. So this is the kind of outstanding question that, yes, we can provide evidence for a plausible model, but it is still a plausible model. In terms of the future of use of SEM in language testing research, I think we're going to see more uses of SEM in terms of the constructing new exams or revising new exams. I know that we're using that constantly from now on. In the past, it wasn't used in the revisions of exams. Now it is. One question you may ask is the difference. Why do we do it today and we didn't do it 20 years ago? The reason is simple. SEM requires enormous power. In addition to enormous power, when I say power, I'm talking about computer power. You need user-friendly software. In the past, the software used for SEM, they were not really user-friendly. In terms of other work within the SEM that can happen, or actually there's a lot of work happening at the moment within the language testing, I say that the language learner strategies and also test takers characteristic, these are the interesting areas that a lot of people now are looking into, and they're looking in the context of impact studies and consequential validity. They're taking all these variables, and SEM is a very good tool to bring them all together and come up with a comprehensive model.
Well, thank you for explaining SEM to us and for sharing your understanding of the research that's been done using SEM and your own experiences.
Thank you.